Slide is visible, right?
Yes, ma'am.
So today we are going to talk about path testing and procedure testing. Or in the last class, I discussed about the structural testing. In the structural testing, I explained the statement testing, branch testing, and the condition testing. And today you are going to study about the path testing. So first you are going to study about the path testing. What is path testing and how it can be used for testing the implemented program. Next you are going to study about the procedural testing. So once I complete the procedural testing, the chapter will be completed. So first we'll see why we are going for the path testing. So decision and condition adequacy criteria force the consideration of individual program decisions. So in the last class you studied the decision and the condition testing, and these testing techniques force the consideration of individual program decisions. Means when we are considering each statement there, we have to consider the individual program decisions, but it is not possible always for all types of programs, because sometimes though a fault is resolved only through the exercise of some sequences of decisions, because only a particular path is going to be followed when we are using the decision or condition testings. Even though the condition adequacy criteria is satisfied, but some of the paths may be not covered. So hence we have to go for the path testing, so that in the path testing all the paths in the program will be exercised at least once. So for that we have to consider the test case. We are considering the number of test cases where the test suite capital T consisting of the set of test cases or number of test cases. Now let us consider the test suite T for a program P which satisfies the path adequacy criteria if and only if for each path P of program P there exists at least one test case in T that causes the execution of that particular path. Means here we are considering the given or implemented program P. For that we are going to apply the test cases. So test cases are present in the test suite capital T. Okay, then the capital T, that is the test suite, satisfies the path adequacy criteria only when each path of the program P that is executed at least once. Okay, so each path of program P is executed at least once when we are using different test cases which are present in the test suite. Then we say that the test suite T satisfies the path adequacy criteria. Understood? It is the definition is somewhat similar to statement, branch, and conditions. So there in the statement adequacy criteria, we'll see that all the statements are executed at least once, and in the branch adequacy criteria, we'll see that all the branches in the program are going to be executed at least once. Similarly, for the condition testing, we are considering both the conditions, that is true and false, and we'll check that at least uh, each condition is satisfied at least once in the given program. Similarly, for the path testing, if number of paths are present in the program and the goal is all the paths or each path in the program are to be executed at least once, then we say that it satisfies the path adequacy criteria. So this is equivalent to stating that every path in the control flow graph model of the program is exercised by a test case in T. Means the number of test cases are present in the test suite, and every path in the control flow graph model of the program P is exercised by at least once. So if we consider the example of the CGI code for the program, see here, the CGI code for the program that we are representing in the form of a control flow graph. See here, this is the CGI program that is represented in the form of a control flow diagram. See here, so many blocks are there: A, B, C, D, E, F, G, H, I, M, L. Right? These are the number of blocks are present in the control flow graph, and the paths are nothing but the edges, right? So here, see here, each block is connected through the edges, and each block is called as the node, and nodes are connected through the edges, right? So when we are using the path adequacy criteria, and our main motto is we have to follow all the paths, or all the paths in the program to be executed at least once, then we say that the path adequacy criteria is satisfied. So this control flow diagram is represented in the form of a simple control flow diagram. There we are representing each node as just the node. We are not including any explanation for this. Here, this is the case. See here, we are representing it as the just nodes A, B, M, C, D, E, F, G, H, I, and L. So the given control flow diagram of the CGI code is represented just by the nodes. Okay, so this is also a control flow diagram. Here the description for the nodes are not included. We are just representing them as the nodes A, B, C, D, E, A, B, C, D, E. F, G, H, I, and L, and M. Okay, so these are the different nodes present in the control flow graph. So when we are using the path adequacy criteria, each path or the each edge from one node to another node should be executed or should be exercised at least once. Then we say that it satisfies the path adequacy criteria. Then we are calculating the path coverage. C path of T for the given program P is the fraction of paths of program P is executed at least one test case in T. Suppose let us consider that there exist 12 paths, and if 8 paths are executed when we are applying or when we are using the test case, then we say that C path is equal to 8 by 12. Means how much? 75% of the path is covered, or 0.75 path adequacy criteria is met. So, but it is not satisfying the full path adequacy criteria. So, we say that the test so T satisfies the path adequacy criteria only when C path is equal to 1. When C path is equal to 1, when all the paths present in the program are executed at least once, then we say that it satisfies the path adequacy criteria, right? So decision and condition adequacy criteria consider the individual program decisions, as I explained, and the path testing focuses on the combinations of decisions along the paths. See here, if we consider this path, see here, at each case we have the decisions, either true or false decisions. See here, either true or false decision is there. Hello. Just a minute. Okay. ಆನ್ ಮಾಡಿದ್ದೀನಿ, ನೆಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ, ಬರ್ತಾ ಇಲ್ಲ. ಓಕೆ, ಅಪ್ಪಂದ್ರಲ್ಲಿ ಆನ್ ಮಾಡಿಸ್ಕೊ. So here, what we are, just a minute. See here, path testing focuses on the combinations of decisions along the path. See here, if we consider the decisions, either it may be the true decision or the false decision, because for each condition we have the two conditions, path or the false or the true conditions. All these conditions are going to be considered in the path adequacy criteria. See here, path testing focuses on the combinations of decisions along the path, and when we say that it meets the adequacy criteria, each path must be executed at least once. And C path is calculated by using the number of executed paths divided by number of paths present in the program. So if 12 paths are present in the control flow graph or in the program, and if 8 paths are executed, then it becomes 8 divided by 12. It is equal to 0.75. Understood? In this way, we are calculating the C path. And when C path is equal to 1, if 12 paths are there in the program, if all 12 paths are executed, then we say that C path is equal to 1, and that satisfies the path adequacy criteria. Clear? Next, we'll move on to the paths behind the individual branches. So here we are exploring the sequences of branches or the paths in the control flow graph, and many more paths exist than the branches. See here, we have number of paths exist. So here dotted line indicates the more number of paths, and when compared to the number of branches, we have more number of paths. See here, different paths exist for each true and false condition. Then practical path coverage criteria. Here we are considering the number of paths present in the program with loops is unbounded, and the simple criteria is usually impossible to satisfy. For example, if you consider any loop exists, in this case it may leads to the infinite loop. See here, we have the one loop. See here, from C to E, E to L, and L to B. Then once again becomes B to C and C to E. So this, let us consider this loop. This may loop some for some point of time. It may results in the infinite loops. So if infinite loops exist in the program, then just by using the simple criteria, it's very difficult to cover all the loops, because the program leads to the infinite loops. So infinite loops are very difficult to cover by using just a simple criteria. Hence we are going for some other criteria which is feasible for covering all the loops in the program. So in the feasible criteria, what we are going to do is we are partitioning the infinite set of paths into a finite number of classes. So first we are identifying the paths which are infinite. Then those paths are divided into the finite number of classes. Then if finite number of classes exist, then it is very easy to cover those paths. Okay. So in the simple criteria, it is impossible to cover the infinite loops, and hence we are going for the alternate criteria, that is, or we can say the more improved criteria. In that criteria, we are identifying the infinite set of paths. Then the infinite set of paths are divided into the number of finite classes. Then we'll use the criteria by limiting the number of traversals of loops, then the length of the paths to be traversed, and the dependencies among the selected paths are going to be defined. Then we are using the feasible criteria so that it covers all the paths in the program. So to cover all the paths in the program, we are using the feasible criteria, and this feasible criteria can be obtained by limiting the number of traversals of loops, then the length of the paths to be traversed, and the dependencies among the selected paths. So by using these three, we are limiting the number of paths in the program. So if we are limiting that, then we can easily cover the paths which are present in the program. Understood? So next we are going for the boundary interior path testing. So here in the boundary interior path testing, we are grouping the paths that differ only in the subpaths they follow when repeating the body of the loop. So let us consider an example here. So in this case, let us consider at condition C. Here for this, we may have the interior body of that particular loop. See here. So for if you consider it for C to D, D to E, D to G, G to H, and H to L, and L back to B, in this we have the interior path from G to H, H to L. It's an interior path when compared to the outer side path. So then in such cases, we are considering the interior paths. See here, for the boundary interior path testing, we are considering the paths that differ only in the subpaths they follow when repeating the body of the loop. So we are considering the subpaths when repeating the body of the loop, and follow each path in the control flow graph up to the first repeated node. So here, whichever the first repeated node that we are considering first. So for the B, it is a repeated node. So here from A to B, no repetition or no loop exists. But from B, we have the loops. So one is for the, see here there are two conditions for B. So if it is false, then it is simply moved to the node M and it exists. But if there is a true condition exists, then it is moving to C, from C to D or E, depending on the true or false condition. So if it is a false condition, then it is moving into the node E, and if there exists a true condition, then it is moving into the D. Once again, at the D node, we have two conditions, true or false. If it is true, it is moving on to the G, and if it is false, it is moving on to the F. So in this control flow diagram, first we are identifying the node which is the first repeated node in the control flow graph. So in this control flow graph, the first repeated node is the B. So that is going to be identified first. Then the set of paths from the root to the tree of each leaf is the required set of subpaths from boundary interior coverage. Here the set of paths from the root of the tree to each leaf. Here set of paths from root of the tree to each leaf. So if A is the root of the tree, then what are the leaves here? We have the one loop L, and then we'll consider the B loop, right? So L is, so from B, if we are moving on towards the down, so first A is the root node, and for the root node A, we have the leaf node B, and B consisting of two more leaf nodes C and M, and for C, two more leaf nodes D and E, and for D, two more leaf nodes F and G. For G, two more leaf nodes H and I, like that. We are going to identify the leaf nodes for each intermediate node starting from the root node. Here the root node is A, and as we move down the control path, the control flow diagram, we are identifying the leaf nodes for each intermediate node. That is, the set of paths from the root of the tree to each leaf is the required set of subpaths from boundary interior coverage. See here, A is the root node, and intermediate node for this is B, and from, or the leaf node for A is B, and for B it is C and M, like that. So for each intermediate node, we are identifying the leaf nodes starting from the root node. So here, that is the request, it is the constructed tree which covers all the leaf nodes starting from the root node. See here, root node is the A, and then we have the B. From B, only M exists. So that is one path. A to B, B to M is one path. Next one is from A to B, B to C, C to E, C to L, and L is back to B. Right? That is one more path. See, A to B, B to C, C to E, and E to L, and L to B. Like that, we are identifying each path in the control flow diagram. And once we test the implemented program by using the different test cases, then we'll check whether each path in the given control flow diagram is executed or not. If each path is executed, then we say that it satisfies the path adequacy criteria. Okay, understood. So, but it is in the boundary interior path testing. So, what is the main difference in the uh, uh, in the boundary interior path testing and just path testing? So in the path testing, we are considering the whole control flow diagram, and we are going to identify, or we are going to check whether all the paths are covered or not. But in the boundary interior path testing, what we are going to do, we are going to identify the subpaths for the path in the program, and we are identifying the repeated node, and for each repeated node we are going to construct that path starting from the root of the tree. So this is the case. See here, each intermediate we are identifying the nodes starting from the node root node, and we are identifying the repeated nodes, and then we are constructing the paths starting from those repeated nodes. Okay, so here B is the repeated node, C is the repeated node, D is also a repeated node, and G is also a repeated node. So for these nodes, we are identifying the subpaths, and subpaths are constructed. You can check it here. See here, for the D, two subpaths exist, one through F and one through G, and similarly for G, two subpaths exist through H and I. So like that, we are identifying the subpaths for the entire control flow diagram. Then we are going to construct the tree structure, and once we are employing the different test cases for the different test cases for the implemented program, we'll check whether all the paths in the program are executed or not. If all paths are executed, then we say that the path adequacy criteria is satisfied. Understood? So when path adequacy criteria is satisfied, then C path value is equal to 1. This is not required. Okay, leave it. Next, we'll move on to the limitations of boundary interior adequacy criteria. As we know that if there exists a loop in the program, then it may leads to the number of different paths, and these paths may grow exponentially, and sometimes it may leads to the infinite loops. So let us consider this case. If A, then statement S1 is executed for condition B, S2 is executed for condition C, S3 is executed. Similarly, if number of conditions are there, then the number of paths are going to be grow in an exponential manner. So the subpaths through this control flow can include or exclude each of the statement SIs. Here S1, S2, S3 are the number of statements. For each control, the different statements are going to be executed. So that in total n branches results in 2 power n paths that must be traversed. Why it is 2 power n? Because here for each condition, if condition, we will have two answers. Either it is the true result or the false result. So for each condition, we will have two results, true or false, and hence it is represented by 2 power n, where n indicates the number of branches. And why it is 2 power 2? Because for each condition there exist two results, true and false. That's why we are representing in terms of 2 power n. So if n branches, the subpaths through this control flow can include or exclude each of the statements SI, we can have the total n branches results in 2 power n paths that must be traversed. So choosing the input data to force the execution of one particular path may be very difficult because there exist 2 power n paths. Then we have to choose a test case, or we have to choose the input data so that particular path is to be executed, and that is the very tough task or the difficult task in the path testing. Why? Because there exist more number of paths, and what we are interested only in executing a particular path. So execution of a particular path among the 2 power n paths is very difficult. We'll see the loop boundary adequacy criteria. So it is the variant of the boundary or interior criteria that treats the loop boundaries similarly, but it is less stringent with respect to other differences among the paths. We'll see this criteria. A test suit satisfies the loop boundary adequacy criteria if and only if for every loop for at least one test case, the loop body is iterated by 0 times, or iterated by once, or iterated by more than once. So loop body means, if we consider this case, so here for this D, H, E and L, so there exists a loop body within the for G, right? There exists the loop body for G. So this condition we are checking whether it is executed or iterated. Loop body is iterated for 0 times, or for 1 time, or more than 1 time. So we are considering these conditions to check the loop boundary adequacy criteria, whether the loop body is executed for or iterated for 0 times, 1 time, or more than 1 time. So it corresponds to the cases that would be considered in a formal correctness proof for the loop. So if it is executed or iterated for more than once, or it is more than or at least once, then we say that it is satisfying the formal proof correctness criteria. Next one is the linear code and the sequence jump adequacy criteria. So here we are considering the linear code sequence and the jumps. Jumps are nothing but jumping from one statement to another statement, or we'll say from one path to another path. So that we are considering, and the linear code sequence and jumps. Here the sequential sub path in the control flow graph starting and ending in a branch, and TR1 represents the statement coverage, whereas the TER2 represents the branch coverage, whereas TERN plus 2 represents the coverage of n executive linear code sequence jumps. So here TER1 which represents the adequacy criteria for statement testing, and TER2 it for the adequacy criteria for the branch testing, and the third one is for the linear code sequence and jump adequacy criteria. So here why we are considering this, because there exist additional path oriented coverage criteria, okay, that do not explicitly considers the loop. So here the linear code sequence jump, it is not explicitly considering the loops, because it considers the paths to a fixed length. See here, it is not considering the explicit paths, but it is considering the paths to a fixed length. See here, if we represent the path length is equal to 2, then this method checks or verifies the paths which are having the path length of 2. It is not stringently or strictly following the particular, or it is not strictly saying that particular path to be followed. It simply says that, or will check whether the path length, or will give the path length based on the given path length. This method says that any path can be followed. For example, see here in this program, let us consider that the path length is equal to 3. So we'll just give the path length is equal to 3. Then it may follow any path where the path length is equal to 3. So is there any path there exists the path length is equal to 3? 1, 2, 3. It is not there. Only this particular path is there, right? A to B is 1. Sorry, B to C. What the path length is 2. Let us consider that the path length is equal to 6. So if the path length is equal to 6, then we'll see which path exists with the path length is equal to 6. 1, 2, 3, 4, 5, and 6. So this comes, right? A to B 1, B to C 2, C to D 3, D to F 4, and F to L 5, and L to B. This is 6 path lengths. And similarly, we'll see other whether other paths exist with path length is equal to 6. So if there exist more number of paths with path length is equal to 6, then any path can be followed. So that is the case. So it is not strictly saying that the particular path to be followed. Instead, we'll define the path length. So based on the path length, the test case can follow any paths where the path length is equal to 6. So that is the case in the linear code and sequence jump adequacy criteria. Next, we'll see the cyclomatic number. So the cyclomatic number is nothing but the number of independent paths in the control flow graph. Then which path is considered as the independent path? So it is not depending on the previous paths, or it is not depending on the other paths, or the result will not depend on the other paths. Then we say that such paths are said to be independent paths. Then a path is representable as a bit vector, where each component of the vector represents an edge, and the dependence is ordinary linear dependence between the bit vector. So here E represents the number of edges, and N represents the number of nodes, and C represents whether the edges are connected or not. Then these are the components of the graph. Then E minus N plus C for an arbitrary graph. Then E minus N plus 2 for a control flow graph. So here we are considering the control flow graph. For the control flow graph, it is E minus N plus 2. So these are the examples for the control flow graph. So for this, the value is equal to E minus N plus 2. It is the control for the control flow graph, where E is the number of edges, N is the number of nodes, and C indicates whether those nodes are connected through the edges or not. So here we have the number of nodes. We have to check whether those nodes are connected or not. So these nodes are connected. So A to B is connected, B to M is connected, C here, M to C or C to M, no connection. So it is then the number of connected nodes for this is equal to 0. Understood? So here we are identifying whether the nodes are connected or not. Each node A, B, C are nothing but the nodes, and E represents the number of nodes, and uh, uh, AC represents whether the nodes are connected or not. Sorry, E represents the number of edges and N represents the number of nodes. How many nodes are there here? So 2, 3, 5, 9, 11 nodes are there here. So 11 nodes are there. N is equal to 11 and the number of edges is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 edges are there. So number of nodes is equal to 11 and number of edges is equal to 15, and after that we have to check the number of connected paths. So here each node is connected. See here A to B is connected, B to M is connected, B to C is connected. Like that we have to count whether the number of connected edges. Okay, so for the control flow graph, it is equal to E minus N plus 2. Then cyclomatic coverage counts the number of independent paths that have been exercised or that have been executed relative to the cyclomatic complexity. And so this is about the cyclomatic adequacy, and this completes the path testing. So in the path testing, we are mainly concentrating on whether all the paths in the program are executed or not. So the next one is the procedure call testing. So this is not so important because by using the procedure call testing, it is very difficult to test the adequacy criteria. So here this procedure call is used to measure the coverage of the control flow within the individual procedures, but it is to not well suited for the integration of the system or for the system testing. So this particular procedure called testing is not suitable for integration or system testing, but it choose the coverage granularity commensurate with the granularity of the testing. And if the unit testing is effective, then faults that remain to be found in the integration testing. And the testing efforts should focus on the interfaces between the units rather than internal details. So here, whenever we are using the procedure called testing, it is effective only for the unit testing, because when we are testing the entire program in the module wise or unit wise, then we can make use of the procedure called testing. Because if we are using it for the integration or the whole system testing, then there may be a chance that the faults which are present in the program cannot be identified, hence it is not used for the integration or system testing. And the procedure entry and the exit testing, because each procedure may have the multiple entry points and the exit points. If the procedure is having the multiple entry points and exit points, such as the Fortran program, then we are using the entry and exit testing, and the same entry point may be called from many points. So this is about the procedure called testing, and this is the classification of the path testing. So here we have the theoretical criteria and the practical criteria. So this is the last topic. I'll complete in 2 minutes. Okay. So this is the classification. In the classification, we have the practical criteria as well as the theoretical criteria. So in the theoretical criteria, we are just concentrating on the theoretical concepts and satisfying the loops or the paths. But in the practical criteria, in order to satisfy the adequacy criteria, we are going to employ the different test cases which are present in the test suite, and those test cases are employed on the implemented program in order to test the adequacy criteria for the branch testing or the condition testing or the loop boundary testing. So this is the classification, simple one. So here in the theoretical concept, we have the path testing, in that boundary interior testing and the compound condition testing. So here we are only concentrating on the theoretical concepts, and here the loops may grow into the infinite loops or infinite number, but in the practical case that is not the case. So we are using the different test cases and we'll check the adequacy criteria. So this completes the structural testing. So in the next class, I'm going to start the new chapter that is present in another textbook. Okay. Any doubt in the path testing? Any doubt in the path testing? Yes? No. Okay. I will disconnect so that you can connect to other class. Okay. If you have any doubt, you can message me. Okay.